Hi everyone, for my final culminating project, I will be analyzing GDP per capita versus other variables. I feel as though other variables can impact the GDP per capita in a country greatly. For example, the life expectancy at birth in a country typically is a good indicator of how medically advanced and wealthy that country is. Countries with higher life expectancies at birth will likely have highly developed, easily accessible healthcare. I feel that these technological advancements can translate to wealth, and countries with higher life expectancies will also have higher GDP per capita figures. Infant mortality rates may also impact GDP per capita in a similar manner for similar reasons, where good healthcare means lower infant mortality and therefore better economies, more developed countries, higher GDPs. The mean or average is calculated by adding up all numbers in a dataset and dividing that sum by the total number of data points. It represents all values of the dataset, including outliers. In this case, the average life expectancy at birth for the 42 countries being analyzed is approximately 71.95 years. As well, the average infant mortality rate per 1,000 live births is approximately 23.13 deaths per 1,000 births. The average GDP per capita in current US dollars of the 42 countries being analyzed is approximately $13,231 US dollars and 49 cents. The median is the data point which lies in the middle of a data set when ordered from smallest to largest. It is also referred to as the 50th percentile. In this case, the median life expectancy at birth for the 42 countries being analyzed is approximately 74.18 years. As well, the median infant mortality rate per 1,000 live births is approximately 14.25 deaths per 1,000 live births. The median GDP per capita in current US dollars of the 42 countries being analyzed is approximately $6,227 US dollars and 23 cents. The modal interval is the interval of data points which shows up the most. The interval size for infant mortality rates is 10 deaths per 1,000 births. The modal interval for infant mortality rates per 1,000 births of the 42 countries being analyzed is 0 to 10. The interval size for life expectancy at birth is 7 years. The modal interval for life expectancy at birth is 71 to 78. The interval size for GDP per capita is 10,000 US dollars. The modal interval for GDP per capita in current US dollars of the 42 countries being analyzed is 0 to 10,000. The range is the difference between the maximum data point and the minimum data point. In this case, the ranges of all three datasets are incredibly high. The spreads between the highest and lowest values for each variable are very large. The range of life expectancy at birth is approximately 30.83 years. The range of infant mortality rate per 1,000 live births is 74.4 deaths per 1,000 live births, and the range of GDP per capita in current US dollars is approximately $54,101 US dollars and 85 cents. The IQR is the difference between the point that is higher than 25% of the data, the 25th percentile, and the point that is higher than 75% of the data, the 75th percentile. It is the range of the middle half of data points. In this case, the IQRs of each variable are much lower than the respective ranges. The IQR of life expectancy at birth for the 42 countries being analyzed is approximately 9.94 years. The IQR of infant mortality rate per 1,000 live deaths is 27.55 deaths per 1,000 live births. The IQR of GDP per capita in current USD for the 42 countries being analyzed is approximately $12,208 US dollars and 13 cents. The standard deviation is the typical distance any given data point is from the average. In this case, the standard deviation of life expectancy at birth is considerably lower than that of the other two variables. The standard deviation of life expectancy at birth for the 42 countries being analyzed is approximately 7.79 years. The standard deviation of infant mortality rate per 1,000 live births is approximately 20.14 deaths per 1,000 live births. The standard deviation of GDP per capita in current US dollars for the 42 countries being analyzed is approximately $15,969 US dollars and 11 cents. There is a much greater level of consistency in the life expectancy at birth for the 42 countries being analyzed than both GDP per capita and infant mortality rate. The distribution type for the infant mortality rate per 1,000 live births for the 42 countries being analyzed is positively right skewed, where the data is mostly on the left side of the histogram, but the mean is considerably higher than the median as the data has some high points much higher than the median. The same is true for GDP per capita, which is also positively right skewed. As well, the box plot shows the box for both cases, for both sets of data, to be on the left side of the box plot. The left whisker is considerably shorter than the right whisker, and the average is higher than the median as it is pulled to the right by the long right whisker. On the other hand, the distribution type for the life expectancy at birth for the 42 given countries is negatively/left skewed, where the data is mostly on the right side of the histogram, but the mean is lower than the median because the data has some low points much lower than the median. The modal interval includes the median. As well, the box plot shows the box to be on the right side of the box plot. The right whisker is considerably shorter than the left whisker, and the average is much lower than the median, as it is pulled to the left by a long left whisker. The slope of a line represents a measure of increase/decrease of the dependent variable for a 1 unit increase in the independent variable. The slope of the line of best fit for GDP per capita versus life expectancy at birth is 1466, meaning that for each increase of 1 unit in a country's life expectancy at birth, the GDP per capita increases by $1466 US. The slope of the line of best fit representing GDP per capita versus infant mortality rate is negative 489, meaning that for each increase of 1 unit in a country's infant mortality rate, the GDP per capita decreases by $489 US. The y-intercept of the line represents the value of the dependent variable when the independent variable is 0. In this case, the y-intercept of the line of best fit representing GDP per capita versus life expectancy at birth is negative 92,231, meaning that when life expectancy at birth of a country is 0, the GDP per capita for that country would be negative 92,231 US. In this case, the y-intercept does not make sense. GDP per capita cannot be negative. The y-intercept in this case is only a measure to allow the model to fit between the given domain, the lowest and highest given life expectancies at birth of the 42 countries being analyzed. The y-intercept of the line of best fit of the linear model representing GDP per capita versus infant mortality rate is 24,538, meaning that when infant mortality rate per 1,000 live births of a country is 0 deaths, the GDP per capita for that country is 24,538 US. In this case, the y-intercept does make sense, as the GDP per capita of a country is typically higher when the country's infant mortality rate is lower. It is entirely possible that a country with an infant mortality rate of 0 would have a GDP per capita of 24,538 US. For GDP per capita versus life expectancy at birth, the correlation coefficient is approximately 0.715. Therefore, from the correlation of GDP per capita of each country and the life expectancy at birth of each country, the relationship between the two variables is said to be a strong positive relationship. For GDP per capita versus infant mortality rate, the correlation coefficient is approximately negative 0.616. Therefore, from the correlation of GDP per capita of each country and the infant mortality rate of each country, the relationship between the two variables is said to be a moderate negative relationship. The point representing the USA on each scatterplot has the greatest impact on both models. If the dataset for GDP per capita for the 42 countries was normally distributed, the point representing the USA's GDP per capita would be at the 99.5th percentile. When the point is removed from the linear model representing GDP per capita versus life expectancy at birth, the model changes from y equals 1466x minus 92,231 with r equals 0.715 to y equals 1377x minus 86,589 with r equals 0.723 approximately. This implies that the USA's GDP per capita in current US dollars is much greater than that of other countries. Its removal results in a line of best fit that better fits the data as evident by the higher R value, indicating a stronger positive relationship between the two variables. The smaller slope shows a slower rate of increase for GDP per capita relative to life expectancy at birth, when the USA's incredibly high outlying GDP per capita value is removed from the data. When the point representing the USA is removed from the linear model representing GDP per capita versus infant mortality rate per 1,000 live births, the model changes from y equals negative 489x plus 24,538 with r equals approximately negative 0.616 to y equals negative 454x plus 22,914 with r equals negative 0.62 approximately. This implies that the USA's GDP per capita in current US dollars is much greater than that of other countries. Its removal results in a line of best fit that better fits the data as evident by the higher absolute value of R, indicating a stronger yet still moderate negative relationship between the two variables. The two variables of GDP per capita in current US dollars and life expectancy at birth have a common cause correlation. Although more evidence is needed to link a third factor as the factor causing both GDP per capita and life expectancy to increase simultaneously, plausible explanations include the fact that countries with higher life expectancies are typically wealthier for a birth of reasons and therefore have higher GDPs per capita. Countries with high GDPs per capita typically have good economies and higher average incomes. Higher incomes imply better access to housing, education, and health services as well as other items, which often lead to improved health, lower rates of mortality, and generally higher life expectancies. In other words, a lower life expectancy does not directly cause a country to have a higher GDP per capita. Rather, the fact that the country is wealthy and developed causes it to not only have good healthcare/quality of life, resulting in higher life expectancies, but also a good economy, resulting in a higher GDP per capita. As well, a country having lots of resources, a strong presence in certain sectors, etc., results in good employment prospects, in addition to a stronger economy. Good employment prospects translate to higher average incomes and a better overall quality of life, which results in a higher overall life expectancy. Good resources lead to a strong economy, resulting in a higher GDP per capita. The two variables of GDP per capita in current US dollars and infant mortality rate per 1,000 live births also have a common cause correlation. Although more evidence is needed to link a third factor as the factor causing GDP per capita to increase as infant mortality decreases, plausible explanations include the fact that countries with lower infant mortality rates are typically more developed, with better, more easily accessible healthcare, better economies, and a generally better standard of living, and therefore have higher GDPs per capita. Countries with high GDPs per capita typically have good economies and higher average incomes. Higher incomes, again, imply better access to housing, education, and health services, as well as other items, which often lead to improved health, which manifests in the form of lower infant mortality rates. In other words, a lower infant mortality rate does not directly cause a country to have a higher GDP per capita. Rather, the fact that the country is wealthy and developed causes it to not only have good healthcare, resulting in lower infant mortality, but also a good economy, resulting in a higher GDP per capita. The line of best fit in the scatter plot showing the relationship of GDP per capita in current US dollars versus life expectancy at birth with outlier values removed shows that countries with higher life expectancies generally have higher GDP per capita values. This is further corroborated by the work done in Section 4. The correlation coefficient shows that the relationship between the two variables is a strong positive relationship, meaning that the line of best fit fits the data pretty well. As outlined in Section 6, although a country's life expectancy does not directly affect its GDP, countries with higher life expectancies will generally also have higher GDPs, due to the common cause correlation which exists between the two variables. The same factors leading to high life expectancies also lead to high GDPs, where wealthy countries with good economies also have advanced healthcare. The line of best fit in the scatter plot showing the relationship of GDP per capita in current US dollars versus infant mortality rate per 1,000 live births with outlying values removed shows that countries with lower infant mortality rates will typically, but not always, have higher GDP per capita values. This is further corroborated by the work done in Section 4. The correlation coefficient shows that the relationship between the two variables is a moderate negative relationship, meaning that the line of best fit is not a poor fit for the data, but it's not quite a strong fit either. As outlined in Section 6, although a country's infant mortality rate does not directly affect its GDP, countries with lower infant mortality rates will generally also have higher GDPs due to the common cause correlation which exists between the two variables. In other words, the same factors leading to low infant mortality also lead to higher GDPs, where countries which are developed enough to have advanced healthcare preventing high infant mortality generally will also have stronger economies. Although the conclusions drawn here are a good means of raising further discussion on the topics being examined, there are some areas of improvement that could be made with the study. There's bias in the nature of the data being analyzed. Although the measurement tool itself is not flawed, as the data is all unbiased statistics from reputable databases, there is some sampling bias present. As the data only looks at 42 countries, there are biases in that although the conclusions may be true for the countries being analyzed, including the data for the other 153 countries in the world may affect conclusions. As well, there is further sampling bias present in the form of non-response bias. There is a non-response bias in that my sample again does not accurately represent the world, due to the sheer number of countries missing from my data. As the data for these other countries was not readily available in the given table, my study was not representative of the wider population, due to important segments of the population being missing. The reality is that many other factors can play into the GDP per capita of a country and affect the conclusions of my study. Some countries may have, for example, a good quality of life despite not having strong economies, therefore a low GDP per capita and a high life expectancy, while others may have strong economies due to resources and other things, but lower qualities of life / worse healthcare, resulting in high GDP per capita and low life expectancies / high infant mortality. In this regard, the small sample size could have skewed my results in that the only countries being analyzed were ones which had high GDPs per capita measures in conjunction with high life expectancies / low infant mortality, and vice versa. The non-deliberate exclusion of other countries could also affect conclusions in that my data does not represent the whole world, but rather only the countries I surveyed. Example, for the 42 countries being analyzed, those with higher life expectancies have higher GDP per capita measures, and those with lower infant mortality rates have higher GDP per capita measures. If I were to conduct a similar study in the future, this time with more time and resources, I would do it with all 195 countries in the world, as opposed to just these 42. This would give me a fully accurate representation of whether or not the conclusions I reached were correct. I would know in actuality whether countries with higher life expectancies have higher GDP per capita measures, and whether countries with lower infant mortality rates have higher GDP per capita measures. The replication of my results with the entire population of the world would further prove the reliability of my study. As well, I would conduct the study repeatedly at a set time interval, for example at 10-year intervals, so as to ensure the consistency of my results over time and therefore the reliability of my study. I am confident in my conclusions as they logically make sense. A country with a higher life expectancy is generally wealthier and will therefore most likely have a stronger economy, resulting in a higher GDP per capita. As well, a country with a lower infant mortality rate is generally going to be more developed and will therefore have a stronger economy, resulting in a generally higher GDP per capita. Nevertheless, given more time and resources, I would be interested in the further exploration of the topics at hand and their relationships.